So chapter 4, we have to kind of review chapter 4 a little bit, Nate, okay, before we can move on to the actual stuff from chapter 4. So chapter 3 was all about learning like lines and how to graph them, right? We had,
that was smooth, you know.
Yeah. So we knew how to graph lines given intercepts. We knew how to do y equals mx plus b. We talked about how to graph vertical and horizontal lines. And then we talked about slope, right? Do you guys remember all that stuff? We had the quiz on it. You guys did pretty good. Right, Kimmy? So first thing I want to review is slope. And Mike asked the question, are we going to have homework? I don't think so because we already did the slope IXL, right?
Yep.
So I think we're pretty good on that. So slope was defined as what, Louis? What's slope? So what's slope? Slope, what is it? All right, well, we talked about slopes being related to hills, right? We had uphill, downhill.
Oh, it's down.
In Maddie's terms, we talked about side hill, and then we had a cliff, right? But Louis, what was really kind of like the in-depth definition of slope? You're describing it to me. What was it? What does slope measure? Louis, this is why we have to pay attention, buddy. Slope measures the steepness of a line. So, Louis, I don't mind you listening to music, but you got to focus, okay? If we can't listen to music and like get what I'm teaching, then the music goes away, right? Makes sense. All right, so slope measures the steepness of a line. Okay, and then we'll talk about this over here. The symbols for slope is M, that's what we use. Okay, Nate, there's like that kind of cursive M. So the slope of a non-vertical line, just meaning not a line that goes up and down, through 2 points, we call it x1, y1, x2, y2, is the ratio of blank, which is the change in y, to the blank, which is the change in x. So it's the ratio of the rise to the run. And Louis, this is what you're kind of talking about. How far down does a hill go? Well, do you guys run at all? I'm real big into running right now. Have you ever ran? Yeah. You don't like it, do you? No. What is your least favorite thing to run? When you ran, what was your least favorite thing to run? No, not how far. Like whenever you're running and you got that certain part of the run, right? You're like, oh, this is the worst. What was that one part? 3/4 of the way down. What happened at 3/4 of the way down? You wanted to follow the ground and cry? Anybody else run?
I know.
You run? What's the worst part of a run? Yeah. I think you guys are missing the worst part of a run. It's the uphill, right? Nothing is worse than running uphill. But running uphill is not bad if it's like a really, really long hill, right? If it's really long and you're just running uphill gradually, you're like, oh, it's not bad. It does take forever. But the worst part of a run is when you're running up media station. You guys familiar? Why is that the worst? It's so steep, right? So slope is the change in rise. Like how quickly do you go up? Over how long does it happen? So Louis, when you're talking about down, it's only part of it, okay? Down is only part of slope. So it depends on how quickly do you go down. If you go down like, you know, like gradually, not a big deal, okay? So here, slope equals the rise over the run. So there are three formulas here, okay? Well, mainly two. So we have this, which is rise over run. That's great for graphs. And then we have this guy up here, which is great for when I give you 2 points, okay? Got that, Louie? In a graph, this is what it looks like. So the change in y is how much we're going up and down. The run, which is the change in x, that's over how long do we do that. Now, the bigger your slope is, that means the larger the change in y is over the shorter amount of x. That's why media stations stink so bad, because you go straight up. Like in a quarter mile, you go up like 200-300 feet. You're like, oh my gosh, this is so bad. When you run it, you feel like you're walking, because you kind of are, because your steps aren't going length anymore. They're just going up. All right. Does that make sense to you? Now, slope doesn't matter if it's like, you know, steepness doesn't matter if you're going up or down. Steepness is just a generic thing. A downhill slope can be very steep too, right? Kind of think going down black diamonds while skiing or snowboarding. All right. So here, first one we're going to talk about, it says find a positive slope. Positive is generally, we're just talking about going uphill, okay? So that's why it's positive. So it says find the slope of the line. What I want everybody to do is highlight the 2 points on the graph. Okay. And when I give you a graph, Annie, I'm just asking you to count the blocks. Okay. Nate, does that make sense to you? Yep. I'm counting the blocks. So how many blocks up am I going? Well, 1, 2, 3, 4. That's where they got the 4 from. How many blocks to the right? 1, 2, 3, 4, 5, 6. That's where they got the 6 from. And my slope, as you can see, it's right here. That's 4, 6. And then we try to reduce that to 2/3, because we talked about it. When you're late for class and you're running up the stairs so you get there on time, okay, you skip steps, right, Louis? Louis could care less if he's late for class. All right. But I know Mike, when he's late for class, he's trying to get there. So he's sprinting up those stairs, he's skipping steps. 4, 6, skipping steps. 2/3, you're hitting every step. It's like running stadiums down in the stadium. Better man than I. Okay, now what is this working here, Louis? Well, Louis, if I don't give you the graph and I just give you these points, they labeled the points x1, y1, and this point 2, 6, x2, y2, and then they just did 6 minus 2 over 2 minus -4. And that's where they got this work. So this work in here, well, that comes from when I give you the points, okay? So this is what that looks like. Notice, did I give you a graph? No graph, right? Right, Cody, no graph. So all I want you guys to do here, first step, and those of you guys are here, first step is always to label your points. It's over there. All right, so I want everybody to label your 2 points, x1, y1, x2, y2. Everybody at home, label your points, x1, y1, x2, y2. x1, y1, x2, y2. Now, step number 2 says to do what, John? What's step number 2 over there on the board? On the board. It's either red. Right equation. Now we're going to write our slope equation. Our slope equation is m equals y2 minus y1 over x2 minus x1. All right, so I'm going to write my equation. I'll write it all. So write your equation. And then, Chucky, what's the third step? So I am going to substitute -1 in for y2 and 2 in for y1. So I have -1 minus 2. And now I'm going to do 4 minus 5. Nate, what's the last step? Nate, you're playing Snake.
Sure.
When we're supposed to be following along, you're supposed to be on the notes. Did you scroll down? Click on chapter 4. Hey, you didn't click on chapter 4. Did you click on the notes in chapter 4? Yeah. Oh, okay. So my fourth and final step is solve and simplify. So -1 minus 2 is -3. 4 minus 5 is -1. -3 over -1 is 3. Can you kind of remember this a little bit? Just a little? All right. So again, we're going to start out by writing our equation, which in this case is y2 minus y1 over x2 minus x1. Then I'm going to substitute. So I'm going to do 6 minus 3 over 4 minus -2. 2 negatives make a positive. So that gives me 6 minus 3 is 3 over 4 plus 2 is 6. That's 1/2. Last but not least, this one is like, don't want to do this because it's got fractions, right? But you guys have a calculator, so we can kind of type it in. We're still going to do the same thing, y2 minus y1 over x2 minus x1. And then I'm going to substitute it in. So I get -3 minus 5 over 1/2 minus 9/2. -3 minus 5 is -8. 1 minus 9, because we subtract the numerators when we're dealing with fractions. 1 minus 9 is -8 over 2. But when we divide by a fraction, we actually multiply by the reciprocal. The -8's cancel, so I'm left with 2. We okay? Cody, at home, you okay?
Yeah, I think so.
All right. Negative slope is just the opposite. We're just going down. So my answers are all going to be negative. So here, let's highlight our 2 points, which are 3, 5, and 5, -1. So to get from this point on the left to the point on the right, I simply count down. 3, 4, 5, 6. Went down. That's a negative direction. So down 6. 1, 2, 3. To the right 3. So that's where they got the slope of -6 over 3, which simplifies to -2. Now, how did they get this work in the middle? Well, they plugged in the points like we just did. Okay. Any questions? Okay, no questions?
Nope.
Now, as Maddie said, this is a side hill. So a side hill is a horizontal line, okay? And these, if we highlight our 2 points, notice there is no rise. We're not going up anywhere. So that's 0. We only go 1, 2, 3, 4, 5, 6. 6 to the right. So they have 0 over 6, which is 0. The work in the middle is because they've labeled their points and filled it in. That's where that came from. You okay? Okay. And the last type of slope is a cliff, a vertical line. Notice here, how do I get from this point to this point? Well, I'm going down 1, 2, 3, 4. I went down 4, but I didn't run anywhere. So that's where the -4 over 0 comes from. But you can't divide by 0. If you plug that in the calculator, you get this word, error, undefined. So this slope is undefined. To get their work that they have, we simply label our points and plug it in. And that's where the work comes from. Now, you guys have 2. I want to know the slope of these 2 lines right here. So everybody go ahead and find the slope of those 2 lines. So follow the steps, label your points. Maybe. I haven't seen her. Louis, did you get this? Neat. You getting this? Nate, you doing it? What are you writing it down on?
I don't know.
You don't have paper or pencil?
Can I write on this thing?
I don't know. All right, that should have been enough time. So number 3. Okay, I'm going to label my points x1, y1, x2, y2. Then I'm going to write my formula, which is m equals y2 minus y1 over x2 minus x1.
Yep.
So I have m equals 3 minus -2 over 1 minus 1. 2 negatives make a positive, so I have 5 over 0, which is undefined because I can't divide by 0, which makes sense because notice my x values are the same. If my x values are the same, it's going to be a vertical line. Kind of thinking about the opposite there. Notice my y values are the same here. That's going to kind of tell me that this is a horizontal line and my slope should be 0. So I'm going to label it x1, y1, x2, y2. Write my equation. Substitute 7 minus 7 over 4 minus -3. 2 negatives make it positive. So I have 0 over 7, which is 0. Louis, did you write that? You did? Cool. The summary of it. Positive slopes have slopes that are greater than 0. They are going uphill. Negative slopes are going downhill. They have a slope less than 0. Then we have a slope that is horizontal. It's a slope of 0. It's going to be a horizontal line, no slope, side hill. And then we have a vertical line. That slope is undefined. So this is a little classification so that you can kind of go to this and see, like, hey, does my answer make sense? All right, here we go. Ready, Louie? You getting ready to drive? Vroom, vroom, in the car? All right, gas prices. The table shows the cost of a gallon of gas for a number of days. Okay, you know, gas fluctuates, right? With the economy, like when we had the snowstorm that went through Texas, everything kind of shot up because it's where we get our oil and stuff like that from. So find the rate of change with respect to time. So Louis, it says rate of change, the change in cost over the change in time. Change in cost over the change in time, right? Yeah. Now, they picked day 3. What day would you like to pick? What? Day 1 or day 5? Oh, day 5. So Louis is picking day 5. Louis, what was the price of gas on day 5? $2.19. And it was day 5, right? Yeah. So Louis, what's 209 minus 219?
209 minus 0.8. Oh,
just take your time. If yeah, it's negative 0.10. And I'm going to write it like that because 1, that 0 is legit, and 2, we're talking about dollars and cents, right? So cents have 2 decimals. Look at that 0. It's good. It is good 0. Now, what's 3 minus 5, Louis? -2. So what is negative 10 cents over -2? Well, we know the negatives are going to cancel out, right? So it's 10 cents divided by 2. No, think about it. You have a dime. What's half of a dime?
25.
Close. 5 cents. So Louis, what this says is it's 0.05, which is a nickel per day. So the rate of change in price is 5 cents per day. So that's what gas is changing for this, 5 cents per day. And it's positive, so that means it's going up. All right.